Hey, Math 20-2s. Today we're going to start some statistics, do a little bit of review and preview. So, statistics is a name given to the branch of applied math concerned with the collection, analysis, and interpretation of mathematical data and numerical data. Collection of data by various methods has been covered in previous math courses. The data can be collected from a population or from a sample. All right, population is the whole thing, or from a sample of the population. Once the data is being collected, it can be analyzed in a variety of ways. In previous courses, we've represented a collection of data by some kind of average value. For example, when students receive their unit test marks, they often ask the teacher what was the class average. So we call these things measures of central tendency. Once data has been collected, it's useful to be able to describe the data by one single central value. In previous courses, we've studied three different types of central values or averages. Mean, median, and mode are the measures of central tendency. Here's what each of these are defined as. So the mean is the mean of a population is denoted by the Greek symbol mu. The mean of a sample is denoted by the symbol x with a bar over top of it. The mean of a population and the mean of the sample are both calculated using the exact same method. Mean is calculated by adding all the data values and then dividing by the number of data values. So this is usually what we call our average, and when you talk about class average, they usually talk about the mean or your average value. All right, so you add up all your data values and divide by the number of pieces of data. Your median is determined by first sorting the data into numerical order, so either ascending or descending. If there are an odd number of data values, then the median value is the middle. If there are an even number of data values, then the median is the average or the mean of the two middle data values. And finally, the mode is the easiest one to understand. The mode is the data value which occurs most often, i.e. has the highest frequency of occurrence. It's possible to have multiple modes or no mode. All right. So keeping these three definitions in mind, let's do some examples. Example 1. The data below represents the time taken to the nearest minute for a high school student to drive to school on each of the last 10 school days. Calculate the mean driving time for this data. All right, so we're going to add all these pieces of data together. So our mean will be, actually that was for a sample for a population, which is all the data we have, should be the mu. We'll add up all these pieces of data and divide by 10. There are 10 pieces of data there. So let's get a sum for all this. All right, let's add all these up. So we've got 11 plus 10 plus 19 plus 16, 15, and 14. 13, 12, 17, 15. So that gives us 142 pieces of data. Sorry, 142 is the sum of our data. We've got 10 pieces of data. So our mean should be 142 divided by 10. So that is 14.2. And these are the time taken to the nearest minute. So that's 14.2 minutes is the average. State the mode of the data. Well, the mode is the piece of data that occurs most often. So if you look at this data, I notice that there are two number 15s. So that's the one that occurs most often. The mode of this data is 15. It occurs twice, which is the most of any piece of data there. Hideki's unit test marks in English 20 and Math 20 are given below. Calculate his median mark on these subjects. So step 1, if you go back and read your definition of median, you have to rearrange these into an order, either ascending or descending. So either largest to smallest or smallest to largest. So let's go, for English, let's go smallest to largest. So the smallest number here is 58. And then we have a, 58, then we have a 65. Next smallest is 67. Then a 71. A 78. Another 78. And an 80. All right, so that would be our piece of data from smallest to largest. Definition of the median is the piece of data that's exactly in the middle. So the middle piece of data here, if I go 3 in from the left or 3 in from the right, the middle piece of data is 71. So the median mark on the English 20 exam was 71. You guys do the same thing. No, the math one's going to be a little more difficult, so let's look at the math one. Again, let's do it lowest to smallest, lowest to highest. Lowest number is 61, then 72. Looks like we got a 74 next, then a 78, and then we've got an 84 and an 86. All right. This one has an even number of data, so there is no exact middle piece. Up here we had 7 pieces of data. Right, so the exact middle of 7 is 4. 3 in from the left, 3 in from the right. Our fourth piece of data was 71. But we've got 6 pieces of data. There is no exact middle. So you look at the 2 middle pieces of data. 74 and 78 are the 2 middle pieces. So if you want to find your median, we were told on the last page that we have to figure out the average of the 2 middle pieces of data. So our 2 middle pieces of data are 74 and 78. So we add those together and divide that by 2. So that's 152 divided by 2, which gives us an average of the 2 middle pieces of 76. So that's our median. Example 3. If the mean of a set of data is 7, find the value for x. So now we're told that the mean is 7. And we're asked to find what the value for x is. So we know that the formula for the mean is to add up all the data values. 10 plus 4 plus 7, 12, 9, 4, and 6. If you add all those up, we get 52 plus x divided by their 2, 4, 6, 7, 8 pieces of data. All right. So if we're told the mean is 7, and that's the formula for the mean, then I substitute this value in for the mean. So 7 should equal 52 plus that unknown value of x divided by the 8 pieces of data. So how do I solve this equation for x? Well, I'm going to multiply both sides by 8, get rid of that denominator of 8. So 8 times 7 is 56. Here, the 8 divided by 8 is 1, so I'm left with 52 plus x. Subtract 52 from both sides, and x is 4. Let's look at example 4. The data below represents the number of touchdowns thrown by Jason, the center high school quarterback, during his high school football career. Calculate to one decimal place, if necessary, the mean, median, and mode for the number of touchdowns per game. So let's figure out the mean. Mean of this population, we're going to add all these pieces of data together. So we can do this really quickly in our heads, right? 0 plus 1, 1, and 2 is 3, 4, 6, 7, 9, 11, 12, 15, 16, 18, 19, 21, 22, 24, and 3 is 27. So we have a total sum of 27 divided by how many pieces of data are there. If we went through and counted, it looks like there are 19 pieces of data there. So our mean would be 27 divided by 19, which if you figure that one out to one decimal, like it says, if necessary, one decimal place, I think we get 1.4. So what is this number of touchdowns thrown per game? Touchdowns per game, 1.4 touchdowns per game. That's his average. That's his mean. If we want to figure out the median, well, we have to rearrange this data in some kind of order. So we will go again from lowest to highest. So I have 1, 2, 3 zeros. I have 1, 2, 3, 4, 5, 6, 7 ones. we have 1, 2, 3, 4, 5, 6, 7 2s, and we have 1, 2, 3s. So I've now arranged this data from lowest to highest. I've got 19 pieces of data. That means if I go 9 in from the left and 9 in from the right, I get 18 pieces of data covered. So our median is the exact middle piece right there. So the 10th piece of data is exactly in the middle of 19 pieces of data. So the median of this stuff would be 1 touchdown per game. And finally, if we're asked to find the mode of the set of data would be the piece of data that occurs most often. Well, we said there were 7 1s and 7 2s. So if there's 7 of each of those, the mode equals 2 separate values. The mode equals 1 and 2. So you can have more than one mode. Alright? They both occur 7 times. So 1 and 2, and these would be touchdowns per game. Part B, Suzanne drew a frequency table to represent the data from up above. If you look at the array we had listed for the median, we notice there were 3 zeros, there were 7 1s and 7 2s, and there were 2 3s. Show how Suzanne could use the data in the frequency table to calculate the mean, median, and mode for the number of touchdowns per game. Alright, so Suzanne wanted to use this table to figure out the mean, the average. We still have to add up all the pieces of data. So 3 times for 3 games he threw 0 touchdowns, plus 7 games he threw 1 touchdown, plus 7 more games he threw 2 touchdowns, and finally in 2 games he threw 3 touchdowns. So that's the total number, total sum of all our data. And the frequency, or the number of pieces of data we had, if we add these up, 3, 7, 7, and 2, 3 plus 7 plus 7 plus 2, that's how many games we played. So to find our mean, we still get the same value in the numerator there, 3 plus 7 plus 14 plus 6, that's still 27, over 3 plus 7 plus 7 plus 2, that's 19 pieces of data. So we still get the same average, 1.4 touchdowns per game. So if you use a frequency distribution table like we have here, that's what the method would look like to find the mean. The median's a little bit easier to find if you're given this frequency, if you're given a frequency table, because we know if I add all these up, we know there's 19 pieces of data here, right? So we add the number of games up, we got 19 pieces of data. We're looking for the middle piece of data. Well, the middle piece of data is the 10th piece. So we've got 3 zeros, and we've got 7 1s. So the 10th piece of data would actually be a 1, right? 3 plus 7 is 10. If I wrote this out in a list, the 10th piece of data would be a 1. So our median is still 1 touchdown per game. And the mode is even easier to find because the mode is the piece of data that appears most often. Well, the table tells us how many times these pieces of data are appearing. 1 appears 7 times, 2 appears 7 times, so the mode is 1 and 2. It tells us that. Alright, so let's see what our calculator can do for us. We've done all that by hand. Alright, so on page 202, let's calculate the measure of central tendency using the statistics feature on our graphing calculator. So we will use the following data values as an illustration. It gives you the things we're supposed to do. I want you guys to follow along on your calculators, and we'll go through this example. Alright, so let's get to your calculators. Keep your page open. On page 202, step 1, it tells you to clear all previous lists by going second function, so hit your second function button, and then above the plus sign it says memory, and if you go down to number 4 it says clear all lists. So number 4 there is clear all lists. You press enter, clear all lists, yes, you want to do that, you press enter, and all our lists are cleared. It tells you that. Done. Step 2 asks you to access the list feature by pressing the stat button and then edit. So here's on our calculator, we press the stat button. Number 1 is edit, so we just have to press enter. And we see our lists are there and ready to go. Enter the data values into list 1. So our data values that we were given in the example at the top of page 202 are 10. Enter that. 987. 14, 14, 13. 5, 11, 6. 16, sorry. And there we go. We've entered all our data into list 1. Exit the list using the quit command. So quit means second function. Above the mode button is quit. Now to calculate the descriptive measures, which are the mean, median, and mode, all sorts of other measures, press stat and then scroll to calculate. So hit your stat button. Now you got 3 tabs at the top. Go over to calculate and select the one variable statistics, which is the first one, number 1. So we just have to press enter. One variable stats. So we want to do that for list 1. That's what we put it into. The calculator automatically assumes that you put the data in list 1, but just to make sure, you can also hit second function. Above the number 1 you see list 1. So it wants us to do the one variable statistics on the data we put in list 1. So now if we press enter, we get all this data. So what do all these things mean? Well, this X bar right here indicates the mean. So the mean or the average is 10.7. All right. The median is represented by the word MED. So we have to scroll down to find out what the median is. Median in this case is 10.5. And the calculator does not figure out the mode for you. Let's talk about what all these other things indicate on this display. All right. So if we go back to the top, we've got the mean. We've got the sum of all our data. So you add all those numbers up, you get 107. We don't really ever have to use this one, the sum squared. These two are standard deviations for the population and for a sample of the population. All right, we scroll down. Our minimum value was 5. The first quartile, so 25% of the data was 8 or below. The median value is 10.5. Third quartile, 14% of the data was 14 and below, and our maximum value was 16. So that's what all those things in the stat descriptive measures tells you. All right. So class example 5 asks you to state the mean, median, and mode for the data in the example above. All right. So we did that. The median we know is 10.5. We see it on the screen there, and the mode we know is 10.7. So the mean we figured out to be 10.7. The median, it told us that value was 10.5. And the mode is the piece of data that occurs most often. So if we go back to the top of this page, which piece of data occurs the most often? Well, I see 2 14s. No, another piece of data occurs more than that. So the mode of this data is 14. All right. Now, the following procedure is used when the data is represented in a frequency table. So let's use the data from class example 4 to illustrate this procedure. So again, you've got this page open on page 203 Let's go to our calculator and do everything it's going to ask us to do here. So again, clear all the previous lists. Go second function. Above the plus sign is the memory. And go down to number 4, clear all lists, and press enter. So that just cleared the data we typed in there for the last page. Access the list feature by hitting stat and then edits the first one, so just press enter. And again, our lists are all cleared. Enter the data values, number of touchdowns per game into list 1, and the number of games into list 2. So in list 1, if you look at our data values, number of touchdowns per game was 0, 1, 2, and 3. Hit the right arrow button, get into list 2, and the number of games that he had 0 touchdowns was 3. The number of games he had 1 touchdown was 7. The number of games he had 2 touchdowns was 7, and the number of games he had 3 touchdowns was 2. So we've entered that table into our calculator. Exit by using quit, so second quit. Again, find the descriptive measures. So again, hit your stat button and scroll over to calculate. And again, we want one variable statistics, but now we have our data in 2 places. Our data is in list 1 and list 2. So let's go second list 1, and then you have to hit your comma button above the number 7, and second list 2, which is above the number 2. So now we're doing one variable statistics for the data that's in list 1 and list 2. Now if we press enter, we'll get the same kind of values that we had last time. All right. So here's our mean, 1.4210526332. Here's the sum of the data. Here's the sum of the data squared. Here are two values for our standard deviation. There were 19 pieces of data. Yep, we knew that. There were 19 pieces of data. Minimum data value was 0. First quartile was 1. So the median value was 1. It tells us that. And it tells us the maximum value is 3. So our median is 1, and our mean was 1.4 to the nearest tenth. So those are the values we calculated earlier. So at the bottom of the page, it asks us to write these values. So the mean was 1.4. The median was 1. And again, the calculator will not figure out the mode for you, so we have to do that one ourselves. And from that frequency distribution table, it's pretty easy to figure out the mode, right? There were 7 1s and there were 7 2s, so the mode is the number 1 and 2. All right. You should now be able to do all the questions that you're assigned, from numbers 1 through 11. Away you go.